Hello, welcome everybody to Northern Craft. So, today we are going to understand strain gauge from strengths of material. So, what is strain gauge? Strain gauge are the device which are used to measure in and one particular direction. It helps to measure the longitudinal strain in any one particular direction on the surface of the body subjected to external loads. So again I will repeat, strain gauge are devices which are used to measure the longitudinal strain in any one particular direction on the surface of a body subjected to external loads. If there is a subject, if there is a surface and it is applied to an external load upon it, in this time there is a device called strain gauge. It looks like this. It looks like this. Positive and negative. So it helps us to find the longitudinal stress in one of the particular direction on the surface of the body subjected to external load. This is the external load applying on this surface. By applying this strain gauge on this surface on which the external load is applied, it helps us to find the longitudinal strain. Now we'll see. So this is our device, strain gauge. We have one positive and negative. Consider R1 is the resistance of the gauge before deformation. R2 is the gauge resistance after deformation. When due to the external load, when the surface deformed a little bit, current on the strain gauge 1 before the deformation will be R1, and current on the voltage 2 before the deformation will be therefore delta I will be I2 minus I1. So by finding the delta I, we were able to determine delta R as well, and we were able to determine as well delta L, which is the longitudinal deformation or longitudinal strain deformation. So del I helps to determine del R, which further del R helps to determine del L, means the change of length. So in our view, strain gauge is a device which are used to measure longitudinal strain in only one particular direction on the surface of body subjected to the external load. So for example, if there is a surface, consider this is the surface of the body. Take one axis as x-axis. Consider this is x-axis. We have placed our strain gauge in this position. Strain gauge A at the theta angle A theta. Then another strain gauge at the theta angle B. This is theta B. And another strain gauge at the theta angle C. So we find strain at theta A angle A will be, due to external load, will be strain at x axis plus strain at y axis whole divided by 2 plus strain at x axis minus strain at y axis whole divided by 2 cos theta excuse me space shortage plus sigma x minus sigma y all divided by 2 into cos theta 2 theta A plus gamma xy upon 2 sin 2 theta A. This is shear strain in xy direction. So we find sigma at strain at theta angle A will be strain at x plus strain of y plus strain at x minus strain of y whole divided by 2 into cos theta 2a plus gamma xy upon 2 into sin theta upon sin 2 theta a. So angle is with respect to the strain gauge in this case. Similarly, if you need to find the angle with respect to, this is our figure, this is x-axis. Now consider this is strain gauge B, this angle at the angle of theta B consider. Now similarly, in this case we find angle theta B, quite similar formula, sigma x plus sigma y whole divided by 2 plus sigma x minus sigma y whole divided by 2 cos 2 theta b plus gamma xy whole divided by sin 2 theta b. And again, if the angle is over here, if the strain gauge is placed over here at the angle theta c, an external force is acting on the surface, strain gauge is placed on the surface at the angle theta with respect to x-axis. So then strain at angle c, theta c will be sigma x plus sigma y all divided by 2 plus sigma x minus sigma y all divided by 2 cos 2 theta plus gamma shear stress on an xy direction and sin 2 theta c. So from seeing these three angles, we can find with respect to each angle the strain, and from solving these three equations, since solving these three equations, theta at angle sigma at angle theta b and sigma at the angle theta a and sigma at angle theta c, unknown values can be found, which are sigma x, sigma y and gamma xy. Since these are the unknown value, and actually we had found sigma theta c by using the strain gauge itself, sigma theta b by using the strain gauge, and sigma theta A by using the strain gauge itself. So now we will see strain rosette. Strain rosette are the combination strain rosette. These are the combinations of three strain gauges. These are combinations. Combination of three strain gauge. Three strain gauge. These are the combination of three strain gauges, and it's used to measure the state of strain at a point on the surface of the body subjected to external load. So it basically helps to find the state of the strain on the point on the surface of the body subjected to external load. So now we'll see types of strain rosette. The first type of strain rosette is rectangular, in which the three strain gauges are placed in a rectangular form. This is the x-axis, this is y-axis. These are three strain gauges, A, B, and C. With the help of these three strain rosette, we were able to find sigma x, sigma y, and sigma xy. So the formula will be sigma theta A will be sigma x, since theta A is equal to 0. And sigma, and we know that theta B is at 45 degree. In the rectangular strain rosette, we place sigma B at theta 45 and theta C at 90 degree. So what happened is sigma B from our general formula will be equal to sigma A upon sigma C upon 2 plus 0 plus gamma xy upon 2. Since we know that in saying in the general formula, here is a sine theta and here it is cos theta, so we know that cos 0 is 1 and sine 0 is 0. So that's why this formula is turned to this face. From the above formula we can say this. Cos 90 is 0 and sine 90 is 1. So the formula becomes this for the sigma B. And by the way, sigma y is equal to sigma C, since as you can see in the figure, it's 45 degree. It's 45 degree. So, and sigma C lies on y-axis only. So the angle between C and y-axis is 0. So that's why sigma y is equal to sigma C. So we found our sigma b, which is equals to sigma a plus sigma c upon 2 plus gamma xy. And if we have to find gamma xy from this, it's really like formulate the previous equation. Just put this will be equal to 2 sigma b minus sigma a plus b sigma c. This will be the answer for the shear stress in an xy direction. Now we will talk about another strain velocity, which is called strain delta velocity. Strain delta velocity. Or delta strain velocity. So it is usually in this type of form with each other at a 60 degree. Strain A, strain B, and strain C. And it's also in this way as well. Degree. This is also 60 degree. Strain B, and this is strain. This is C. Strain dot C. Strain dot B. And whole, and also it's also present in this form as well. Strain dot J. Strain dot B, strain dot C. These are in 120 degree with each other. This is also 120 degree, and this is also 120 degree. So you see what you notice with respect to each figure. With the figure 1, this is figure 1, 2 and 3. With figure 1, we notice that theta A, as you can see in this figure 1, theta A is equals to 0, theta B is equals to 60 degree, and theta C is equals to 120 degree. And if you see figure B, figure 2, in this figure we see theta A is equals to 0 degree again. This is A. Theta B is equals to 60 degree, and theta C is equals to minus 60 degree. Since angles are in this direction. In the third figure, what we notice is theta A is 0, still 0. Theta B is minus 120 degree, and theta C is 120 degree. So these are strain velocity and strain gauge. So what we have done is, first we're going through strain gauge. So what is strain gauge, if anyone asks you? It's nothing but it's a device which are used to measure the longitudinal strain in any particular direction on the surface of the body subjected to external loads. Now how it's used is you have to place it on the surface where the external load is acting, and then you will find the sigma at the theta A, sigma at theta B, and sigma at theta C by the strain gauge itself. And you will got these values, sigma at theta A, sigma at theta B, and sigma at theta C from strain gauge. And by solving these three equations, we will find the unknown, which is sigma x, sigma y, and gamma xy. Then we talk about the strain velocity. Strain velocity is a combination of three strain gauges, as we have talked, and it's used to measure the state of strain at a point on the surface for the body subjected to the external load. It helps us to determine the condition of the strain on the body acted by external load, state of the strain. For example, the strain at the angle theta A will be equal to sigma x. Strain x is equals to strain angle theta A, since theta A is equal to 0. And so already got sigma x will be theta A. And theta B is equal to 45 and theta C is equal to 90. In solving the above general equation, we find this form. And gamma xy will be formed from formulating the above equation. Then we talk about the strain delta velocity, delta strain velocity. In this delta strain velocity, three strain gauges are connected. In a different form, as you can see in this form. In first form, theta A is equal to 0, theta B is equal to 60, theta C is equal to 120. And in the second form, we see theta A is equal to 0, theta B is equal to 60, and theta C is equal to minus 60. And in third form, we see theta A is equal to minus 0, and theta B is equal to minus 120, and theta C is equal to 120. Thank you for watching this video. If you have any doubt, you can comment and subscribe my channel. Thank you and have a nice day.